Friends, in this session we'll be taking some very basic problems based on circles. We'll try to find out the missing angles, missing length of tangents and seconds as well, right? So let's quickly do this. Find the angles denoted by letters X, Y, Z or W. Here, this angle is 35 degree. Now, clearly you can see AC is a segment. I just draw that. Right? So, on this segment, angle B is there, angle E is there, angle D is there. That means X and Y, both of them will also be of 35 degree, because angles in the same segment are also same, or we can say equal, right? So this is very basic property, that angles in the same segment are equal. That means X and Y, both of them will be 35 degree, right? Similarly over here, if I draw this segment BC, angle 30 will be equal to angle Y, and if I draw the segment AD, angle 110 will be equal to X. So that means Y is equal to 30 degree and X is equal to 110, right? Similarly, in this segment AC, this angle is 42 degree. In this case, what will happen? From this segment, the angle made at the circumference will be half than that of the center. So this, from this segment, the angle at the center is X and angle at the circumference is 42. So this angle must be half of this. So X must be double of 42, that's 84. So this X is equal to 84. Just very basic properties of circles we are using over here. And so doing this sort of problems, your concepts will be strengthened. Now here in this case we'll be using the property of cyclic quadrilateral. Sum of opposite angles of a cyclic quadrilateral is 180 degree. Now what is a cyclic quadrilateral? All the four vertices should be on circumference of the circle, right? So this plus this angle, suppose it is 1, it has to be 180, and this suppose it is 2, it has to be 180. Now this and this is also 180 because this is a straight line. So precisely this angle will be Y, because 2 plus Y is 180 and 2 plus 80 is 180. That means Y is 180. Y is 80. Okay, similarly 1 plus X is 180 and 1 plus 75 is 180. That means X is 75. Okay, just you have to see that ABCD is a cyclic quadrilateral. That means sum of opposite angles should be 180 degree. Okay. Now in this case, this angle is 35 degree. This portion is 35. On the segment AB, this angle is made and this angle is made. So W will also be 35 degree. Similarly, on the segment DC, angle X is there and 40 is there. So X will be 40. So X is 40 and W is 35, as simple as that. Okay. Now in this case, this angle is 130 degrees. So this plus this should be 180. Suppose this is angle 2. So angle 2 plus 130 degree should be 180 degree. That means this is 50. Now these four are on the circumference of the circle. That means this angle plus this angle should be 180 degree because it is a cyclic quadrilateral. So angle 2 plus X is 180 and angle 2 plus 130 is also 180. That means angle X is 130 degree. Okay, getting my point? Similarly, angle 135 plus angle Y must be 180 because again it's a cyclic quadrilateral. So angle Y will be 180 minus 135, that is 45 degree. Okay, very simple. In this case, the segment DA is there. So angle 57 and this angle, both of them are in the same segment. So it is also of 57 degree. Now, since BD is passing through the center of the circle, that's O, that means this angle is the angle in the semicircle. That means X plus Y should be 90 degree. Angle X plus angle Y must be 90 degree. Now, if it is 90 degree, it is 57 degree. So W will be what? 180 minus 90 minus 57. So 180 minus 90 is 90. 90 minus 57 is 33 degree. So W is 33 degree. Okay. Now in the given figure, the chord ED is parallel to diameter EC. ED is parallel to diameter EC. We have to find out angle CED. CED, that means this angle. Now I have drawn these two lines over here, this and this. Now this is diameter, so this is angle in semicircle, so this is 50, that means this is 40, right? Now this is the segment EC, and in this segment this is angle 50 degree, that means this will also be angle 50 degree, right? Further, this complete angle will be 90 degree. This is 90. So in this triangle, this is 90, this is 50, that means this is 40, right? Now this line is parallel to this line. So you can see the shape of Z over here. That means this angle and this angle will be same. They will be forming pair of alternate angles, which are equal in case of lines are parallel, right? So this angle must be 40 degree. A very simple conceptual problem. I hope you are clear. Now this problem. In the figure shown below, O is the center of the circle and the measure of arc ABC is 100. We have to find out angle ADC and angle ABC. Now do not get confused. This is measure of arc ABC. That means this is ABC. So measure of arc ABC is 100. That means this angle is 100. Right? Now we have the segment AC. From this segment, the angle made on the center will be double than that of the circumference. So if it is 100, it has to be 50 degree. The first thing. After that, A, B, C, D, all of them are in circle. That means A, B, C, D is a cyclic quadrilateral. If it is a cyclic quadrilateral, sum of opposite angles must be 180. So if it is 50, it has to be 130. Right? So we have to find ADC. So ADC is 50 and ABC is 130. As simple as that. Okay. Now this problem, in the figure shown below, O is the center of the circle. The angle subtended by arc BCD at the center is 140 degree. BC is produced to P, determine BAD and DCP. Very simple. From this segment, this is angle at the center. So from this segment, the angle at the circumference will be half than that of this. So it will be 70 degree. Right? Now A, B, C, D is a cyclic quadrilateral. Right? That means sum of this and this must be 180 degrees. So if it is 70, it has to be 110. Okay. So if this is 110, this remaining portion, that is the outside DCB, that is DCP, that will be 70 degree. Okay. I hope you are clear. So this DCP is 70 degree and angle BAD is also 70 degree. Right. Now in the given figure, ABC is an isosceles triangle with AB is equal to AC and ABC is 50 degree. Find BDC and BEC. So angle triangle ABC is an isosceles. So if this angle is 50, this angle must be 50. So if this 50, this 50, this has to be 80 degree. Right? So next is on the segment BC, this angle and this angle, both the angles will be equal because both of them are on the same segment. So this has to be 80 degree, right? So BDC is 80. Now we have to find out BEC. Now this BECA, this is a cyclic quadrilateral, BECA, and sum of opposite angles must be 180. So if it is 80, it has to be 100 degree. Okay, I hope you are clear. Now in this problem, ABCD is a cyclic quadrilateral in which BC is parallel to AD. ADC is 110, this, and BAC is 50 degree. We have to find out DAC, that is DAC, this angle. Okay. Now, see, this is a cyclic quadrilateral. See, if it is 110, that means it has to be 70 degree. Now this is 50, this is 70, that means the sum is 120, that means this angle must be 60 degree, right? Now DA is parallel to CB. So you can very well see this shape of Z, this, right? That means this and this is alternate angle. Since the lines are parallel, they will be equal. So this is 60 degree, that means this must be 60 degree, as simple as that. Okay. Now here in this case, PQ is diameter of the circle with center O. This is O, not this. Calculate the major angle PQP. Now this PQ is diameter, that means this is angle in semicircle, so it has to be 90 degree. So if it is 42, it has to be 48. Now OB and OQ, both of them are radius, isn't it? So radius must be equal. So this is 48, that means this must be 48. So angle PQP must be 48 degree, right? Just matter of 20 seconds. Friends, now I think you should try the problem on your own. In this problem, in the given figure, O is the center of the circle, AOS is 120, APC and ABC is find out. So if it is 120, it has to be 60 degree, right? If it is 60, it has to be 120 because APCB is a cyclic quadrilateral, right? Simply you have to do nothing. It's just single step and 10 seconds you are getting the answer, right? Take the next one and I'm sure your answer is matching with mine. Now this problem. In the given figure, O is the center of the circle. If angle BOA is 90, angle COA is 110, then find angle BAC. Now the center angle should be 360. So if it is 110, it is 90. That means it is 200. That means it is 160 degree. Now from the segment BC, this is the angle at the center and this is the angle at the circumference. So angle at the circumference should be half than that of this. So if it is 160 degree, it must be 80 degree, right? So angle BAC must be 80 degree. Okay, I hope you are clear. Now in this problem, here we have to find out this missing angle, right? Now this is the center of the circle that is given to us. This is the tangent of the circle, so this angle must be 90 degree, right? Now this is a triangle, so it is 90, this is 57, that means this angle must be 33 degree, right? Now this is 33 degree, this is radius of the circle, so this line and this, both of them are radius, so this angle is 30 degree, that means this angle will also be of 33 degree. Okay. So the complete angle is 180 degrees. So this is 33 degrees. So this is 180 minus 33. That is 147 degree. Okay, I hope you are clear. Now just try this on your own. Very simple problem. We have to find out the measure of this angle. This is 80 degree. This must be 90 degree. This must be 90 degree. So in this quadrilateral, this is 80 plus 90 plus 90, that is 180 plus 80, 260. So this must be 100, right? Now if it is 100, this and this, both of them are same because the triangle is an isosceles triangle. This is radius, this is also radius. So both of them will together be 80. So each of them will be 40 degree. Very simple conceptual problem. I hope your answer is matching with mine. Now further try it on your own. This angle is 104 degree. This is center. That means this angle and this angle must be equal. Sum of these two is 180 minus 104. That is 76 degree. So that means it must be 38. It must be 38. This angle is 90 degree. So this plus this should be 180. So if it is 38, it is 90. It must be 52 degree, as simple as that, and I'm sure your answer is matching. So quickly you can practice with these sort of sums, right? So your basics will be strong, or I can say your basics will be strong enough to deal with difficult problems. Now in this problem, friends, we have to find out the value of x. Now this is actually a tangent. I just write it over here. Say this is P, this is A, this is say M, and this is L, right? So PA is tangent and PML is secant. What is the difference between the two? The tangent touches the circle, but the secant intersects the circle at two different points, right? So this is the difference between tangent and secant. Now tangent and secant, a property is there. I just write it over, that is known as tangent secant theorem. So PM into PL is equal to PA square, right? That is tangent secant theorem. right? Now you just have to put up the value of PA, PM and PL to get the value of X. Now PA is what? 30. PM is 18. PL we don't know, so that is actually 18 plus X. Okay? It's 900, so 18 into 50. So X plus 18 is 50, that means X is 32. That means this length is 32, right? So if you know tangent second theorem, this problem is very easy for you. I hope you are clear, and it's an important concept, so just keep that in mind. Now one more property you have to keep in your mind. See there are two chords in this circle. They are intersecting at this point. Suppose this is O, A, B, C, D, right? So one property is there. This OA into OB is equal to OC into OD, right? So that means if two chords are intersecting inside the circle, product of their segment is equal, right? So OA into OB is equal to OC into OD, right? OC is X, OD is 15, OA into OB is 12 into 10. So X is 8, that means OC is 8. Okay, so small properties if you keep in your mind, it will be easy for you to solve the problems. Now friends, this case, in the previous case the chords were intersecting inside the circle. In this case the chords are intersecting outside the circle. Doesn't matter, the property will remain same. Product of the segment, suppose it is OAB, it is OPQ. OA into OB will be OP into OQ. OA into OB will be OP into OQ, right? So put up the value. 7 into X is equal to 6 into 15. Okay, I'm sorry. OA is 7, OB will be 7 plus X, OP is 6 and OQ will be 6 plus 15, right? So that's 21, sorry. So 7 plus X is 18, that means X is equal to 11, right? So if the chords are intersecting outside the circle, then this, and if chords are intersecting inside the circle, then this, right? So, and the third thing is tangent second theorem, which I have already explained you. There are these three are important theorems whenever you have to find out the unknown length for the tangents and the seconds and the chords. Okay. Now, in this case, we are given the measure of arcs and we have to find out the value of this angle, right? So first of all, I just complete the diagram. Now this is center. This angle is 165. This is 85. That means the remaining angle out of 360. If we deduct 85 and 165, we are left with 110. So this is 110 degree, right? Now this is radius. This is radius. That means the remaining in this triangle, this angle will be, and both the angles will be same. That's 35 degree, right? So if it is 35, it has to be 180 minus 35. That is 145 degree. Okay. Now we can see a quadrilateral FODE, right? This is 145, this is 85, this is 90. So out of 360, this will be the remaining angle. So that's 145 plus 85, 130, 130 plus 90, 220. Sorry, it is 145 plus 85, 230, 230 plus 90, 320, and this must be then 40 degree. Right? So I hope you are clear. Now in this problem, measure of this arc is 160, measure of this arc is 60, and we have to find out this angle. So I just complete the diagram first of all. Now friends, here in this case, we have OWE EC a quadrilateral, right? See, this angle is 60 degree, this angle is 160 degree, that means 160 plus 60, 220. That means suppose I assume this angle is Y, this is Z, so Y plus Z must be 360 minus 220, that is 140, right? Now the other part is, this angle is suppose X, this will also be X, because OW, OF, both of them are radius. This suppose P, this suppose P, right? So what is happening over here? Y plus 2X is 180 and plus Z plus 2P is also 180. So in all it will be 360, right? Here Y plus Z is 140. So this and this is 140. So 2X plus 2P is 360 minus 140. So we can say that's 220. So X plus P is 110. Now this angle plus this angle is 110. This angle, that is Y plus Z plus 60, I'm just write down over here. This angle X plus P is 110. This we have to find out the fourth angle, and this angle is actually Y plus Z plus 60, so that's 200, right? So 200 plus 110, 310, so the remaining is the 50 degree. Okay, I hope you are clear. Now this question, try this on your own and then match your answer and solution with mine. I just complete the figure first of all. Now here, this is the center. This angle is 246. That means this angle must be 360 minus 246. That's 114, right? Now 114 plus this must be 180. And OD is equal to OC. That means this angle must be equal to this angle, right? So out of 180, if we deduct 114, we'll be getting 66. So this must be 33 degree. Now this is tangent. So if this angle must be 90 degree. So if it is 33, this will be the remaining, that's 57 degree. Okay. I hope you are clear. So first we have discussed so many properties, so many theorems, problems based on circles, and now I am sure you must be clear about the basics of the circles, right? Just revise the session, note down each and every concept we have discussed in this session so far, so that will be really helpful while cracking the difficult problems, right? Bye bye.